Hello, my name is Adam. This is the third video in my series to learn how to make Super Mario Bros. In Unity. If you're looking to start from the beginning, there's a link to the full playlist in the description of the video. This video in the series will focus on enemies, player death, and level resets. If you need help at any point in the tutorial, feel free to join our Discord community where we can offer direct help. There is also a link in the description of the video. Please consider subscribing to the channel to support the amount of effort it takes to create a video like this one. It would mean a lot to me and it helps drive the growth of my channel. Thank you. Enjoy the video. Okay, now that we've got all of Mario's movement in place, let's start to focus on other aspects of the game, such as our enemies. But first, before we implement our enemies, let's create a game manager, which will primarily be used in this case to reset the level when Mario dies from an enemy. Let's go ahead and go to our scripts folder, right click, create C# script, and we're gonna call this game manager. Let's go ahead and open this up. Unity, of course, generates some placeholder, kind of boilerplate for us. I like to delete this. And from here, we want to turn our game manager into a singleton, which I don't usually like using singletons. I think they get overused very often. But in this case, I actually feel like it's a pretty decent solution. And of course, our game manager is something that we really are going to be referencing across our entire game. So it kind of makes sense in this case. Now, this will be sort of a simplified version of a singleton, but let's show you how to implement that. So the idea is that there is a single instance of this class here, game manager, and that you can access it from anywhere in your project. So we need to hold a static reference to that one instance of our game manager. So we're going to actually create a property here of type game manager. I'll call this instance, and we'll make this publicly available with a getter, but privately settable, because we only want this class to actually manage this. And then finally here in our awake method, we can assign this. Now in awake, we need to check, is there already an instance available? If there is, then we need to immediately destroy this object, because the idea is there's only a single instance. So if our instance is not null, that means there's one already created. We can destroy immediately this object here, this current game object. Else, if there is not an instance available, then we will assign this to be that single instance. Now, the important thing here is that we tell this instance not to be destroyed when we load. So there's a function Unity provides called don't destroy on load, and we can pass in our game object. So we're saying do not destroy this game object whenever we load another scene. So what this is going to do as you go from level 1 to level 2 to level 3, etc., it will maintain this instance of the game manager across all of them. Now, normally speaking, there's a whole process you go through when accessing this instance. It'll create that instance for you automatically. That's where this isn't like a full proper singleton, but as a simplified version of it, this will totally suffice. Now, the other important thing here is we need to get rid of this instance or unassign it when our object gets destroyed. So Unity has a onDestroy function that gets called, and if the current instance is this, then we need to null it out. So if the object, if our game manager is being destroyed and that is the instance that is being assigned here, then we need to null it out. That way, the next time the game manager object is created, it will reassign itself. All right, so that's our basic kind of singleton game manager, super simplified version of it. We do need to add this to our scene. So this is where, normally speaking, with a proper singleton, you would it would create itself programmatically. You don't even have to add it to your scene. But I'm going to go ahead and add this to our scene here. I'm going to call this, just kind of created an empty game object. I just created an empty game object in our hierarchy, added our script to it, and that's that. You can do this for every one of your stages. So you can just copy this same thing over every one of your stages. And now, even though there will be multiple, each stage will have its own game manager, because of the code we just wrote, once you load level, stage 2, it's going to see, oh, there already was a game manager that was created from stage 1. Okay, let me destroy this one and just keep using the existing one that was already established. All right, so moving on from that, now we can actually start to implement the logic of our game, the kind of the overall game state here. So in our start function, we want to essentially start a new game. So let's go ahead and add a new game function. And we can call a new game from start. Start is a function provided by Unity. This will get run the very first frame that our game manager is enabled and running. New game here, we can reset certain state of our game, which we haven't established yet. So let's go ahead and add some variables to represent the different, game state. So let's create some public variables here. We should probably keep track of which world you're on. And I'm going to make all of these publicly gettable, but privately settable. So it's public getter with a private setter. So world, let's also add one for the stage. So that would be like 1-1, for example. World 1, stage 1, world 2, stage 1, or something like that. And let's go ahead and add some properties for lives. And in the future, we'll probably add some stuff for like how many coins you have collected. But that'll come later when we do power-ups and stuff. So I'm not going to add that right now. All right, so when we start a new game, we want to reset our lives. Maybe you start with 3 lives. You can feel free to customize that. And then we need to load the very first level of the game. So let's add a function called load level. This function needs, let me get rid of this for now. Our function should take 2 different parameters here. One for what world do you want to load? And what stage do you want to load? So then here, when we start our new game, we're going to say load level 1, 1 for stage 1, 1. In the actual load level function, we need to assign these 2 variables or properties. So we're going to say this dot world equals world, and this dot stage equals stage. We need to say this here so it doesn't conflict. Since they're named the same thing, we need to make sure that there's a distinction between referencing these versus the parameters. And then from here, we need to load the actual scene in Unity. But to do that, we need to import using Unity engine.sceneManagement. And then we can say scene manager.load scene. There's a couple different ways we can load a scene. It can load but based on the build index or just based on the name of the scene. So what I'm going to do is use the name of the scene, and I'm going to make sure I name all of my scenes after the world and stage. So we can do some string interpolation here. For example, if you put a $sign in front of the quotes, C# allows you to do some string interpolation, so we can actually put some variables within our string here. So world dash stage. So what this is going to say is if I say, if this gets assigned to 1, this becomes 1. And if our stage, let's say, is 2, this becomes 2. So now I'm loading a scene with the name 1-2. So what that means is in our scenes folder, we need to make sure all the scenes are called 1-1, 1-2, 2-3, whatever, in order for that code we just wrote to work properly. The other thing is in your project, if we go to File, Build Settings, you have to add your scenes to the scenes to build. Otherwise, if you try to load them, it won't work. So make sure you can just drag in your scenes or you can add whatever scene is currently open. So just make sure you add those. These numbers over here, this is the build index. So this is a different way you could handle loading your scenes just based on the index. But in my case, I personally find it a little bit more intuitive to just do it based on the world and stage. All right, so we start, the game starts, we trigger a new game, reset lives, we load stage 1-1, and what else? We need some functions to handle what happens when Mario dies and then resetting the level. So let's add a public function this time. This needs to be public because we're going to be calling this from other code, like in our enemy scripts, for example, when Mario dies. So let's call this maybe reset level, or you could call it like Mario death or something like that. Something to indicate that Mario has died and we need to reset the level. The first thing I want to do is decrease the amount of lives we have by 1. So this is just saying minus equal 1. You could write this as that, but minus works too. From here, we need to check, hey, do you still have some lives left? If you still have, or, you know, if you still have at least 1 life, then we can continue on. We just have to reload the level. So we're just going to load level and pass in the world and stage we're currently on. Otherwise, if you're out of lives, we need to have some kind of game over. And so I'll add another function here for game over. And in game over, you know, there's various things we're going to do. I'm not going to actually implement like a game over right now, but in theory, you could load, like, let's say you could say load scene, and maybe you have like a game over scene or something like that. Or you could do whatever else you wanted to do. So that's up to you. Feel free to decide for yourself what you want to happen when there is a game over. In my case, for now, I'm just going to simply restart the game. So I'm just going to call new game again. And that's it, really. If I really wanted, I could sort of, I could have a delay between that. So if I wanted to maybe delay starting a new game, I could invoke new game after, let's say, like 3 seconds or something. Like, that's an option. So it's up to you. Feel free to customize that, but I'm going to just call new game whenever you get a game over. Now, with that delay I just mentioned, this function is going to be called, in theory, right as Mario dies. But the split second that Mario dies, we don't want to instantly like reload the level and so on. So actually I'm going to have another overload to this function that takes in a delay. Yeah, I'm going to have a public void reset level. And then I'm going to have a float delay here. And all this is going to do is invoke our other reset level based on that delay. So it's kind of that same thing I just showed with kind of triggering our game over, but now we can pass in a delay. All right, and finally, I think the only other function that would be useful for now is to have some kind of next level function, which once again, I haven't set up any other stages, but we can at least get the function in there because it's pretty straightforward. So we have reset level. Why don't we add a next level up here? Next level. All we have to do is say load level, whatever our current world is, and then stage +1. If you are going to build like the entirety of the game with all the different stages, you're going to have to check, like, you know, you'll have to add some additional logic here to check, is this the last stage for that given world? You know, like, let's say if it's world 1, and I don't even know how many stages there are in world 1, but in theory, you could say if the world is 1 and the stage is, I don't know, maybe there's 10 stages. Okay, now I actually need to load level world +1. So we're going to go to world 2, but then back to stage 1. All right, so you can add logic like that in based on how many stages you have, how many worlds you have. For simplicity, for now, I'm just going to say load level, current world, but we're incrementing the stage by 1. All right, so that's kind of our basic game manager. Obviously, it's not like a fully complete in a sense. There's still logic, but that logic is kind of dependent on your game and, you know, how many stages you have, what kind of menus you have, how you want to handle game over and things like that. So feel free to do what you want, but we at least have the structure of everything in place, which is the important part. Okay, next up, let's actually start to implement our enemies. Let's start with Goomba, and we need to create a prefab for Goomba so we can spawn him in the world in different places, or we're going to manually place him at different spots in the world, but we want a prefab so there's consistency between each of those instances. Let's go ahead and start with just an empty object here in our scene. I'm going to call this Goomba. I'm going to reset the transform so everything's at the defaults there. And for Goomba, we're going to need a sprite renderer. We're going to need a rigid body 2D. He will be a physics object. We're going to need some kind of collider to define his collision area. So I'm going to use a circle collider for Goomba. And then we'll add some custom scripts and stuff, but let's actually customize these properties. So for on, let's assign his sprite. I guess this will be animated in a sense, but I'm going to just start with walk 1. And for the order and layer, based on what we talked about during, I think it was the first video where we did the level design, we're going to order everything. And so for our enemies, we're going to be on order with order 2. From here, for the rigid body, let's go ahead and assign that same no friction physics material we created for Mario. Just same thing for them. Make sure they don't kind of clip through, or there's no any weird collision interactions as they walk along the ground. We don't need drag. We don't need gravity. Actually, we do need gravity. Let's maintain gravity. Because these enemies we're going to handle differently than Mario. Mario's movement was very manually done because it has a very custom feel to it. For the rest of the enemies, it'll be more just based on the physics engine. So we will maintain gravity per normal. We can set this to be interpolate. That's just going to smooth out any discrepancies between the physics engine and the rendering engine, because those two systems happen kind of at different intervals. So this just helps smooth it out. Sometimes there's some jittering that can happen between the physics updating and the rendering being updated. For our circle collider, I don't think we really need to change anything here. I guess I'll assign that same no friction material. And let's just move Goomba so we can see what he looks like. Yeah, so that looks good. So he looks normal. Now, in terms of some of the custom scripts we're going to add to him, we of course will create a Goomba script. We're going to create another kind of movement script that's unique to all of the different entities in our game. One script that we can add now that we already have is our animated sprite. So we created this animated sprite script when we did Mario's run animation. We can reuse that for this too. So for Goomba's walk animation, we can also use the same thing. So for Goomba, I have 2 different sprites for his walk animation. So I'll assign both of those and we'll just kind of alternate between. And maybe the frame rate is 0.25. So every quarter second it will rotate. And that's good for now. We of course will add more scripts to this, but I guess one more thing is to change the layer here to enemy. And if you haven't added layers yet, you can click the add layer button, add in a user layer, call it whatever you want. In my case, call it enemy, and you can assign that, go back and assign that. After you add it, you have to actually go back and still choose it. All right, so let's drag this into our prefabs folder here. And there's our Goomba. And now that we've made the prefab, we can delete him from the scene. Okay, now that we have Goomba's prefab, let's go ahead and place a bunch of instances of Goomba in our world here, in our scene. I'm gonna start, you don't have to do this, but I have like all of my different things kind of organized into different things. So I'm gonna do the same thing. I'm gonna right click on my stage object here, create an empty one, make sure it's all zeroed out. I'm gonna call this enemies. This is not needed. It's just kind of an organizational pattern. And I can drag Goomba into here and I can start to place him in my scene at different locations. In the GitHub project, which there's a link in the description for, I do have this references folder, and there's a kind of a grid reference for stage or 1-1 that has the different Goomba, and so you can use the coordinates here to place them if you want. Obviously, feel free to place them wherever you want. It doesn't necessarily matter. But I'm going to use this to just go ahead and place Goomba in our world. And, you know, there's a few different instances of him. So for that, based on those coordinates, I can just say, you know, the first one being 2, 22. And I think in most cases they're all going to be pretty much at 2 to put him, you know, on top of the ground here. There might be, actually there's a few that do spawn like up here on the bricks, but yeah, feel free to just go through that, place them wherever you want. You can add new ones if you're making your own custom stages. Of course, feel free to place them wherever you want. I'll probably fast forward through this as I add them all, although there's only a few, so maybe not. All right, so there we go. I think that's all of them. We've got about 15 or 16 different Goombas in our scene here, all kind of placed at their respective positions. We've got a couple up top there. And that's all for the placement of those. Okay, now that we've got our enemies placed in our scene, we can actually start to implement their movement. For our enemy movement, we're actually going to create a script that we can reuse for all kinds of entities. So for enemies, for our power-ups later on, you know, like the mushrooms as they move around, we can use the same script for all of those. Let's go ahead and go to our scripts folder. I'm going to create a new script here. I'm going to call this entity movement as compared to player movement, so distinguishing those two. For our entities, the movement is a lot simpler. It's way simpler because we're just using the built-in physics engine for this. We don't need to do any custom kind of physics for our entities. I'm gonna get rid of the boilerplate here. And for our entities, we need a rigid body in order to move them. So let's go ahead and establish our private reference to our rigid body 2D. I'll call this rigid body. And if you have followed along this far and watched the other videos, then you should already know this warning. This warning is caused because the name of this variable here is already being used by something in one of the base classes. Now that existing property it's completely deprecated and super obsolete. And so in which case I usually just suppress this warning by saying new, which tells it this is actually a new property, not an existing one, or field, not property, but yeah. You can, of course, also just rename this. You can use an underscore, or you can say M dash. Those are some very common conventions. People use underscores for private fields, or they say M underscore for member. Feel free to do what you want. I like to just simply call it rigid body, and then I suppress the warning with new. We can assign this reference in our wake function like we've done for pretty much everything else. Rigid body equals get component, rigid body 2D. Great. Now we do need some other variables as well. So we need a vector2 for our velocity, and we need some public variables for speed and for direction, which will be a vector2 as well. And we'll default this to left because most of the enemies, I think all the enemies always start moving to the left. We made these public so we can customize them in the editor for each entity, because we'll reuse the script for like our mushrooms and stuff too, and those actually will go to the right, and they might be a different speed. Our enemies, I think, will probably be like a speed 2, where other things might be speed 1. So we made these public so we can customize it. Now, one of the interesting things about the enemies in Mario is they don't become active until they're visible on the screen. So they won't be moving around until you actually see them. So Unity has built-in functions to detect when something has become visible. So they have Unity has on became visible and on became invisible. So this is really convenient because now we can enable their movement when they become visible. So on visible enabled is true, on invisible enabled equals false. And then we can add our on enable and our on disable functions to specify what should happen. So on enable, we want to wake up our rigid body, which will allow it to start moving. And on disable, we want to sleep our rigid body. And we can also clear out the velocity of our rigid body. So in the case, for example, when you hit an enemy, they will disable their movement, so we can start playing their death animation. And so we want to stop their velocity, tell the rigid body to sleep, and so on. And in the case where they become visible, their movement gets enabled, the rigid body wakes up so they can start to actually move. With all of this in mind, we want to make sure that our entities are not moving right away. So we want to actually set this to be disabled on awake. We could just do that in the editor itself, but sometimes you might forget to disable the script in the editor. And so I actually like adding this here to just, that way I don't have to remember to change that enabled state in the editor. The code will do it for me. As soon as they become visible, it gets re-enabled. All right, so from here we can actually implement their actual physics, their actual movement. Let's add our fixed update function, which of course is function Unity provides for us. It gets called at a fixed interval compared to normal update, which gets called every single frame the game is running, but frame rates vary, whereas fixed update doesn't vary. It's always a consistent fixed interval. So that's usually important for physics. So there's consistency in your physics. In fixed update, we need to update our velocity here. So let's start with just the x-axis. Our velocity x will be direction.x times our speed. And our velocity y will be plus equal. This is going to be for gravity. So we need gravity is an acceleration that builds up. So we're going to say plus equal, and we can say physics 2d.gravity.y. This is referring to the gravity that Unity defines. So in your project settings, you can go to edit project settings. There's the physics 2D and there's gravity at the top. You could also, if you wanted, declare your own gravity variable. This could be a float or a vector too. It probably could just be a float. So you could define this yourself if you wanted. What that would allow you to do is customize the gravity per entity. I don't necessarily know why you would want that, but maybe for your version of the game, that could be important. If you did do that, then here it would just be gravity versus the one Unity provides. So I didn't really see a use case necessarily for customizing gravity per entity. So I'm just going to use Unity's. That way it's consistent gravity for everything in the game. Except for Mario, because Mario's movement is very unique. Now for gravity, we need to multiply this by fixed delta time. We basically just need to multiply this by time because gravity is an acceleration that happens over time. So we multiply by time there, so this doesn't happen in one instant, one frame. And now we can actually move our rigid body. So we say rigid body, move position. We're going to take their current position plus that velocity times time again. Because the object, the entity moves over time. They don't just instantly move. Movement gradually occurs over time. And the multiplying twice here is appropriate because gravity is an acceleration. It's meters per second squared. So that's where multiplying by fixed delta time twice, that gives you the square in meters per second squared. All right, lastly, we need to flip their direction when they hit something, when they run into something. So we can use the extensions that we already created for ray casting. We already created an extension method on rigid body to ray cast and see if it hits something given some direction. So we can say if rigid body.raycast, that's us accessing the extension method that we defined earlier. If rigid body.raycast in the direction they're currently moving, well, then we can flip the direction by negating it. So direction equals minus direction. So that'll flip it from left to right, right to left. But you need to do something similar for detecting when they're grounded. So if rigid body.raycast vector2.down, so this is basically checking, are they grounded? If they are grounded, we need to ensure their velocity y is not building up infinitely, because this builds up, it's a plus equal. We don't want it to continuously build up if they're grounded. So we say mathf.max, whatever their current velocity is, and 0. So this says basically the velocity could be either 0 or greater than 0. And if it's greater than 0, that means they're moving up. So that's where, in that case, this isn't even really relevant. But in the case that they're moving down, our velocity is some negative value that keeps building up and up and up, or down and down and down, I should say. We don't want it to become some infinitely large number. So we make it so it stops at 0 essentially while they're grounded. And as soon as they're not grounded, then this won't get run and it'll allow the gravity to take effect again. All right, I think that's it for now. Let's go ahead and test this. We do need to add this script to our Goomba prefabs. Let's open our Goomba prefab. Let's go ahead and add this script. Entity movement here. Now, once again, in theory, this should be disabled initially because the enemies won't become active until they're visible on the screen. But our code is doing that for us. But either way, if you want to do it in the editor or let the code do it, doesn't matter. And one more thing before we actually test, we need to change our collision matrix. So if you go to your physics 2D project, in your physics 2 in your project settings, there's a collision matrix at the bottom, which allows us to turn on and off collision between certain layers. So earlier we assigned Goomba to be on the enemy layer. So make sure you do that. Now we can say which layers can collide with each other. So we actually want to turn off enemy to enemy collision. We don't want enemies to collide with each other because, for example, for these two, this one will hit the pipe and then it'll reverse direction, but then it's going to run into this other one and then it would reverse direction. So they would get stuck in this little loop of just like, moving back and forth just with each other, and it wouldn't be the correct interaction. So we want to allow enemies to actually be able to pass through each other. So we just completely turn off collision between enemies, between each other. And let's go ahead and actually run this and test. All right, so we got Goomba there. Here's a very slow. That's my first kind of observation. They're very slow. So we can always go back to our Goomba prefab and change their speed. Maybe I'll make their speed 2 instead of 1. Okay, there we go. That feels much more accurate. So we've got Goomba. Of course, we haven't implemented like death or anything like that. So I can just kind of walk into them. He even pushes me in a sense. Can hit his head, which, so we still got more to do, which we'll get to. For this one, he should bounce. Yep, he moves off of the pipe. So that looks good. This is where that collision is important to turn off. That way, once again, they can go through each other like that. And now for these, there's going to be some enemies right up here on the bricks. Notice how, they're not moving yet. As soon as I walk over here, boom, now they start moving. So they're just kind of sitting up there waiting for me to enter the screen, and then they start moving. So it allows us to like time out certain events in the game, which is really important for the level design. in the gameplay. So this all looks really good. All right, next up, let's implement some of the specific features to Goomba, such as flattening him when you land on his head, and as well as, I guess, the player death too. Let's go ahead and create a Goomba script. And let's go ahead and add this script. We'll wait. Once we finish, oops, I didn't mean to open that. Once we finish implementing Goomba, we'll add it to the prefab. So for Goomba, specifically here, we need to add logic to detect collision between the player and Goomba, and then flatten Goomba when the player hits him or lands on him. We do need one variable, which is the sprite for Goomba's flat. Like there's a flattened Goomba sprite, so we just need a reference to that sprite so we can update Goomba's sprite renderer. So I'll just call that the flat sprite. Now from here, we need to detect collision between Goomba and the player. So we can say private void on collision enter 2D. This takes a parameter of type collision 2D. We'll call this collision. And the first thing we want to do is check what did Goomba collide with. We can say if collision.gameObject.compare tag is player, well then we know they collided with the player. Of course, you need to make sure your player is actually tagged as player. So if we go to Mario, his tag is set to player. And I think that's a built-in tag that Unity provides, so it should already be there. You just have to make sure you assign it. From here, we need to perform one of those dot tests. So this was another one of our extension methods that we use to perform a dot test. We need to check that the direction that the player hit the Goomba is going down. So if the player hits Goomba while moving down, that implies they landed on their head, on Goomba's head. So we can say if collision, the dot test needs to be performed on a transform. That's our extension method is on transform here. So if collision.transform.test, the other transform is Goomba, so that's just this dot transform. The test direction is going to be down. So if that returns true, then we know that the player is falling down and landed on Goomba's head. In which case we need to flatten Goomba. So let's add a flatten function and we'll call that here. So when Goomba gets flattened, we need to update the sprite renderer. So we'll get component sprite renderer and we'll update the sprite to be that flat sprite that we added up here. We also need to do a number of other things like disable Goomba's collider, disable its movement, disable its animation. So we can go ahead and say get component, collider 2D, enabled equals false. We need to disable their entity movement, enabled equals false. We also need to disable their animation. So animated sprite, enabled equals false. So we can disable all of those things, update their sprite renderer. And we should do the sprite render last, just in case disabling some of these other things, if it has any impact on the sprite renderer, we want to make sure that this occurs last to override those. And finally, we need to destroy this game object. But we don't want to destroy it immediately because then you wouldn't actually see the flattened version of Goomba. So we're going to destroy the Goomba after maybe half a second. Feel free to customize that, but you'll see a flattened version of Goomba for half a second and then he'll just disappear. All right, let's go ahead and test this out. Nope, so that is not working, and that's because I never added the script to Goomba, as I said I would. So let's go to our Goomba Prefab, and let's go ahead and add our Goomba sprite, or not sprite, script. Let's make sure we assign the sprite here. So let's go to our sprites, and find our Goomba flat. There we go. So once again, that will update the sprite render here after all the other behaviors are disabled. Let's try again. Perfect. There we go. So we got the flattened version of Goomba. Nice. So one thing you might have noticed is when I flatten Goomba, I'm not actually bouncing off their head like I'm supposed to. So this is a change we need to make to the player movement script. So open up our player movement script, and at the very bottom, we've already added our onCollision enter 2D function. We need to update this though. We need to check very similarly like we just did, but this time check if the player is colliding with an enemy instead. And yeah, I guess this isn't unique to Goomba. If Mario bounces off or lands on any enemy's head, you're going to bounce off of them. We want to do this first before we do the existing power-up collision. So this one needs to take priority. We'll kind of do the same thing here. If collision.gameObject.layer equals layer mask name to layer enemy, and then this needs to become an else if. So if we collide with an enemy, else if we collide or not collide with a power-up, we do some stuff. But here, if we collide with an enemy, we need to bounce off their head. Now we do still need to do a dot test because you could collide with them just walking into them. So we still need to say if transform. So if transform is Mario here, perform a dot test. We need to test against the enemy. So this could be collision.transform was referring to the enemy. And we want to test going down. This is the case now. We know this is, you've landed on their head and we should bounce off. And the way we bounce off is by setting our velocity y to be a positive value, which will make us move up. And what we could do is say, maybe this is like half our jump force. So we could say like jump force divided by 2, for example. Really, this is kind of arbitrary. It could be anything you want. You can manually just put in some number. From some testing, I found that using half your jump force is like a perfect little nice bounce. But feel free to customize that. And I actually am going to set jumping to true, which we're not jumping, but some of the jumping logic is sort of associated with just being airborne. And so because you're kind of bouncing off and you're airborne now, this will help with some of the existing logic that we added before. Let's go ahead and test this out and see if we actually bounce off of Goomba. There we go. So there's a little bounce. And once again, feel free to customize how much you actually bounce off of them. There we go. So yeah, that actually feels perfect. Boom. Nice. So that feels so much better. Okay, next up, let's implement the death animation for Mario. And actually, in fact, we can reuse this same death animation for any of our entities. So we're going to make this a generic script. I'm going to call this death animation. And let's go ahead and open this up and start implementing. So for our death animation, we will need to change which sprite is active for the given entity. So let's define a public sprite here and call this the dead sprite or death sprite, whatever you want to name that. And let's also establish a public reference to the sprite renderer we want to update. The reason we want this to be public is because the sprite renderer there will be some cases later on where there could actually be different sprite renderers. And so you might need to manually assign this. In most cases, it's just going to be the sprite renderer that is, when you would say get component, it would usually be that, but there will be other cases where you do need to manually assign it. What we could do, this is not necessary, but something you can do is add a reset function. to any of your scripts. This is like an editor specific function that gets called when the script is first reset. Like there's a reset button you can click, or when the script gets added to an object for the first time, this will get called. What we can do is we can assign this kind of a default value using get component. So the same thing we would normally do in our awake function, we can do here instead. That way this sort of has the default value of that sprite renderer that exists on that same object. But in other cases, we can also manually assign this if we want. So, all right, so from here, when our death animation is enabled, so on enable, we need to do a number of things. We need to disable, well, we need to update that sprite. We need to disable all the physics of the object, and then we need to actually do our animation. So let's add functions for each of those. Let's add a update sprite function. Let's add a disable physics function. And we're gonna add an animate function too. All right, so let's start with, oh yeah, and then we'll call each of these. Update sprite, disable physics, and then animate. So for update sprite, we need to, one, enable the sprite render, because there might be cases where it's actually disabled, so we'll enable it. We're gonna set the sorting layer, or the sorting order, to be 10. Earlier we established kind of an ordering from like 0 through 5. So 10 is way beyond those. In theory, this could just be any just very large number. The reason we do this is for the death animation, the entity is going to kind of go up and then fall down, but we want to make sure they always are on top of everything in the scene. Normally speaking, the ground is at a higher order than like the enemies and stuff. But when they die, we need to make sure the object, the enemy or Mario, is on top of those things, so you can actually see them kind of fall off the screen. So we're just going to bump up the order. And then from here, we will assign our sprite renderer sprite to be the dead sprite. And there could actually be cases where there is not a dead sprite. So let's check that that's not null before we assign it. There might be cases where you want to just keep the current sprite that's there, still do the animation, but don't change the sprite. So this could actually be an empty or null value. So if it's not null, we'll update it. But otherwise, if you leave this empty, it'll just be the same sprite that was already assigned. All right, for disabling physics, we need to disable gliders, rigid bodies, as well as we have scripts for player movement and entity movement. And since this death animation is going to be used for players and enemies, we need to disable both player movement and entity movement, because we don't necessarily know which object that this is a part of. But first, let's start with our colliders. Now, there may be cases where our object contains multiple colliders, so we need to get an array of any collider on the object, but Unity has functions for this. So we can define an array of colliders here, and we can say get components, plural, make sure it's plural, collider 2D. So this returns an array of collider 2D, and then we could say for each collider 2D, collider in colliders, we can disable those. And this is really important. We disable the colliders so they can actually fall through, you know, the ground and everything. Let's turn off our rigid body. So get component rigid body 2D. Now there's not a disable or enable property on rigid bodies, but we can set it to be is kinematic true, which will make it so the physics engine isn't affecting that object. And then, like I said, whether this is a player or an entity, we need to disable their custom movement scripts. So we'll say, let's get, in theory, we could do this. We could say player movement enabled equals false, and get component entity movement equals false. The problem with this is one of these is going to be null. So if our death animation is on the player, entity movement's going to be null. It doesn't exist on the player. So then when you say, you know, if you try to access some null object, you get a null reference exception. And vice versa for the entities. An enemy is not going to have the player movement script, so this would be null in that case. So if you try to access a property on a null object, you get a null reference exception. So what we need to do is assign, we'll get a reference to each of those. We'll say player movement equals get component player movement. And we'll say entity movement equals get component entity movement. And we'll null check them. If it's not null, then we can access it and disable it. Same thing for the entity movement. If it's not null, we can access it and disable it. All right, so there is updating our sprite, disabling our physics. Now let's do the actual animation itself. The animation needs to be a coroutine, which will allow us to kind of animate this over time in a custom way without using an update function. So for coroutines, we need to import using system.collections. We need to update the return type of our animate to IEnumerator. And then here, when we call animate, this needs to be wrapped inside start coroutine. And then we'll call our animate function. A coroutine will allow us to actually yield the execution of the function for, you know, under given scenarios. There's different ways you can yield, but this will allow us to animate this in a kind of fixed sequence. We can yield every frame until the animation is finished and so on. All right, so let's establish some timing animation variables, like how much time has elapsed. It will start at 0. What's the duration of our animation? You could always add public variables for these if you want. I'm just going to hard code them. Let's say the animation lasts 3 seconds. Now the animation is the enemy kind of jumping up and then falling back down off the screen. So we could have some kind of like jump velocity. Maybe just hard code that to be something like 10. And we also need some kind of gravity as well. And I'm going to set this to be -36. Very random number. These numbers are sort of based on some of Mario's values, but it doesn't really matter. These can be anything you want. So feel free to customize them to get it to kind of feel and move the way you like. From here, we need to establish a velocity vector, which will be up initially times our jump velocity. And then we need one more vector to determine when, actually, just kidding, we don't need that. So just our velocity here. While our elapsed time is less than our duration, we need to continue animating. And this is where we will yield every frame. So we're going to yield every frame. You can say yield return null. Return null will just wait until the next frame to continue on. But for every frame, we're going to continue inside this while loop. We'll update the position each time. We'll update how much time has elapsed. And then eventually we've kind of reached the duration. The yield will no longer get called. And so then our animation will finish. So here, before we yield, we'll update our position plus equal velocity times time.delta time, where we're changing the position over time. Velocity.y plus equals gravity times time.delta time. And like we've established before, gravity is an acceleration, meters per second squared. So timesing by delta time twice is important. And finally, we update our elapsed time by how much delta time has passed. And that is our animation. You know that this is all just math in a sense, so let's actually see what this looks like so you can better make sense of it. But once again, we're simulating some custom movement of them jumping up, their velocity jumping upwards. And then gravity will take place and make them fall. And because all the colliders and everything are enabled, they'll just go right through the ground and then eventually off the screen. Let's go ahead and test this out. Well, actually, we can't test this out because we haven't triggered our animation from anything yet. Let's go ahead and add this to our player, Mario here. And let's go ahead and drag that in, death animation here. Let me just double check something real quick. We do need to assign this here. Yeah, okay, so yeah, so this is why we needed to make the sprite renderer public, because in the case of Mario, there's two sprite renderers. There's a small version and his big version. We haven't actually implemented like Mario growing in size yet, so we'll get to that later. But for now, I'm just going to assign the small one. And then the dead sprite, there is, we can look in our sprites folder. There is Mario small death. Now the thing is this, in fact, actually this animation will only ever get triggered when Mario's in his small form. Because if Mario's in his big form, if he gets hit, he shrinks. And so this animation is only ever going to be relevant for the small version. So this is actually fine. But this is where we can't just use get component because it doesn't exist on here. And there is get component in children, but there's no way to guarantee it's going to be the right one. So that's why we need to make that public so we can manually assign the correct one. Now we do need to make sure we disable this because it shouldn't play the death animation right when the game starts. So we're going to enable this manually at the right moment. So that's what we need to do next. And to do that, let's go ahead and create a script just simply called player. We're going to add on to this quite a lot later on, but we need at least to establish a couple basic things. So let's get rid of the boilerplate here. This is the script where we'll eventually handle like Mario growing in size. This is kind of like managing the state of the player, of Mario. So we'll handle like him changing in size and things like that. But let's just for now add a public function called hit. So to say Mario was hit by something. Eventually we will add logic to say, okay, if Mario was hit, but he's in his big version, then we need to shrink him. But if he's not in his big version, well, then we need to trigger the death animation. So let's go ahead and, you know what? Yeah, why don't we actually add a little bit of that logic? So let's establish some public references for our player sprite renderer. So if we recall from earlier video, we have two different player sprite renderers, one for small. So I'm going to call it small renderer. And we have one for big version of Mario, big renderer. Okay. And from here, let's add some variables to indicate, oh, and then we also want to add a variable for our death animation. That way we can actually enable it. So we'll call this death animation. I'm going to make this, I guess this could just be private. Yeah, let's make this private. We'll assign this in awake like we usually do. Death animation equals get component, death animation. And then let's add a couple properties to determine if Mario is in his big version or not. So we can have public bool big. This is going to be a computed property here. So we use an arrow symbol, which is basically just a shorthand way of making a getter only property. Mario is considered big if big renderer is enabled. We could do the same thing to say small. He's small if small renderer is enabled. We don't necessarily need both of them because you could say not big, which would imply he's small, but whatever, it doesn't necessarily matter. We can do something very similar to say, well, Mario's dead if the death animation is enabled. All right, so finally here in our hit function, which is public because we're going to call this from our enemy script. If Mario is big, well, then we need to shrink him. We're not going to actually implement this now. That's going to come later because we don't even have the power up in place to make Mario bigger. So we'll come back to this. I'll at least call the function here. So if Mario's big, we will shrink him. Why is my stuff all messed up? There we go. If Mario's big, we will shrink him. Otherwise, we will actually say he's dying. So we'll add our function here called death, and we'll call that here. Now on death, we need to we actually need to disable the small render. So these renders are what, you know, if you remember from earlier, it's updating the sprites based on your movement state and things like that. When we're playing the death animation, we don't want those things to be occurring. We don't want Mario's sprites to be changing because we're assigning the sprite that is being used for the death animation. So I'm going to disable these, both the small and big renderer. That way Mario's sprites aren't getting updated. And then we will enable our death animation. And finally, from earlier when we added our game manager, we have the reset level. This is where we will call reset level. So we can say game manager.instance.reset level. And we can add a delay here, so we can reset the level after 3 seconds. This is actually important because we need to give the animation enough time to finish and play. So after 3 seconds, the animation itself, it also lasts 3 seconds. So as long as it's 3 seconds or more, the animation will play and then the level will get reset. And resetting level, if you recall from earlier, decreases your lives. If you do have remaining lives, it reloads the level, otherwise it'll trigger game over. Okay, so I think that's good for now. Like I said, there's going to be a lot more we eventually do in this, but this is good enough for now. We just need to call our hit function. So this is where let's go back to Goomba. And we can call this if Mario collided with Goomba, but Mario was moving down, then Goomba gets flattened. But otherwise, if Mario collides with Goomba, but they didn't, you know, hit his head, well, then the player is the one who's getting hit, not Goomba. So this is where we can call player hit here. But we need to get a reference to our player script. So what we can do here is say player equals collision.gameObject.getComponent player. So the game object here is the other object we collided with. So that's Mario, or the player, which we already established here. We know it's Mario or it's the player because they're tagged player. So that kind of gives us the safety net to say, yes, we can get the player component because the object we collided with is the player. Now that we have a reference to that player script, we can call our hit function. So once again, if Mario lands on top of Goomba, Goomba gets flattened. But if Mario touches Goomba without touching him from above, well, then the player gets hit. And the player getting hit will check, well, hey, if Mario's big, we need to shrink him, which we'll implement later. Otherwise, if Mario's not big, we play the death. Playing the death disables all those other renders, so the sprite's not getting updated, and triggers the death animation to run. Finally, then the level gets reset. So a lot of different things that a lot of stuff is now becoming very connected with one another. We've kind of starting to establish like the full game loop here. Let's go ahead and test this out. So in theory, let's first just hit him like normal. So good, I didn't die or anything. Oh, and you know what? Hold on. We need to add, we never added, let's go to our Mario prefab. We never added our player script. So let's add player here. I'm going to drag this up just because, and let's assign these two references, small and big. And yeah, make sure this is disabled. I think we're good. Let's try again. So I'm going to kill the first enemy to ensure that I don't die because it's detecting that I'm actually hitting it from above. So that's good. Now for this guy, I'll just let him run into me. There we go. And we see the perfect animation there. And then after a couple seconds, the level resets. Let's look at this one more time. And I'm going to stop it and kind of play it. So we're simulating kind of the movement of Mario jumping up. You can see the animation or the sprite changed. And then we're simulating the physics of Mario jumping up. And then gravity takes place and I fall down. I'm not colliding it with anything at this point because we disabled all the colliders. I can't move or anything because we disabled the rigid body. And Mario displays on top of everything else because we set the order layer to be much higher than everything. And then I fall off the screen and resets. So perfect. This is exactly what we wanted. All right, let's go ahead and implement Koopa now. And this one will be easier in some senses since we already have a lot of the scripts built out that we can reuse. But first, let's start by actually creating Koopa's prefab. Let's create an empty object. I'll call this Koopa. I'm going to reset the transform here. And let's add pretty much the same components we use for Goomba. So we'll add a sprite renderer. We'll add a rigid body 2D. We'll add a circle collider 2D. And we'll add some other scripts too in a minute. Let's go ahead and assign the sprite. We'll start with walk 1. We can use the no friction material on both of these. We don't need angular drag. We will keep gravity because these just use the built-in physics to move them. So we will keep the normal gravity. We can freeze the rotation. I don't think I actually did that for Goomba, but let's go back to Goomba and do that as well. It might not actually matter, but let's freeze the rotation to make sure they don't randomly rotate. And what else? If we take a look at this, so let's move him here. The circle collider is not actually sort of positioned right because Koopa's size is a little bit different compared to the other. He's like 1.5 units tall compared to like Goomba's just 1 unit. So we need to just offset the circle collider. We'll just bring it down 1/4 of a unit. So half of half. And that's kind of positioned around him a little bit better. What else? So I guess this is where we can, let's set the layer enemy. But yeah, this is where we can use the same scripts that we use for Goomba. So well, not all the same things, but we can use entity movement. We'll set the speed to be 2. We can also use the animated sprite for Koopa's walk animation. So we'll set this to 2. We'll drag in both of these. And I'm going to set this to be 1/4 second. We can, yeah, I think that's actually good. Is there anything else on Goomba? So just the unique script per Goomba. We're going to do the same thing. We'll have a unique script that's specific to Koopa. But I think that's good for now in terms of the prefab. We'll probably add to this, but let's go ahead and drag this into our prefabs folder. All right. Now there actually is only one instance of Koopa in this first stage, so we can actually just take this instance already and bring him to the right location. I am gonna drag him into our enemies grouping here. And Koopa is located at 107.2. Although because he's a slightly different size compared to everything else, we do need to bump him up 0.25 so he's position correct, but that is normally where he spawns. Obviously feel free to customize that. You can add more than one if you want as well. But that is it for now. We'll then start to implement his custom scripts. All right, let's add our custom script for Koopa. So let's create, oops, wrong button. Create C# script called Koopa. Let's go ahead and open this up. And this is where some of the logics can be very similar to Goomba. So why don't we just copy what we have for Goomba. I'm going to reset the class name there. There'll be a couple differences. One, Koopa doesn't get flattened. Instead, he enters his shell when he gets hit. So let's rename this to enter shell. So once again, check collision with the player. If the player kind of landed on top of Koopa, he'll enter shell. Otherwise, if they just touched him, walking sideways, the player gets hit. this is not a flat sprite, but should be a shell sprite. So we're going to change Koopa sprite to be in his shell. So we can assign that here. Koopa does not get destroyed when he enters his shell, so we'll get rid of that line of code. But everything else I think is the same. Disable the entity movement. Disable the walk animation. Update the sprite. Disable the collider. Yeah, that all looks good. One thing we might want to do is actually we don't want to disable the... Do we want to disable the collider here? I don't think we actually want to disable the collider because Koopa is still going to actually move. Once you push the shell, it will still move, and so you still need that collider there. So let's keep that. We'll get rid of that line of code because we don't want to disable that, but everything else here is good. We do, however, need to keep track of the state of Koopa. Certain states, like is he in his shell? Is the shell moving? Like was it pushed? Let's add some private booleans to determine that state. So I'll call this shelled to indicate if he's in a shell or not, and I'll say if the shell is moving as well. So when he enters the shell, we'll set this to be true. And then one thing we need to do is this logic here is only relevant if he's not in his shell. So let's add that here, but let's prepend that here. None of this logic matters if he's already in his shell, because if the player touches Koopa when he's in his shell, he won't get hit. Instead, he'll get pushed. And if he's already in his shell, well, we don't need to re-enter the shell either. So that's one thing. Let's go ahead and just test this initially as a starting point. And just to make this quicker to test, I'm going to move Koopa to the beginning here just so I can quickly test this. All right. So we bounced off of him. But nothing actually happened. He didn't enter his shell like he was supposed to. And that's because I didn't add our new script to the prefab. So let's go open our prefab. Let's drag in our Koopa script. Let's move this up. You don't have to move it up, but I'm just going to keep it organized there. Let's assign this sprite here. So Koopa Shell sprite. And let's try again. There we go. Perfect. And I can kind of manually push the shell, but we're going to animate that differently. But at least that's a starting point for Koopa. Okay, so to get Koopa to be pushed when he's in his shell, we do need to make a change to our prefab. Let's open up our Koopa Prefab. So there's one problem here, which is we need to detect collision to know when we should push the shell. But the problem is that same collider is also what we use to determine when Mario dies from touching Koopa. So one thing we could do is actually define a new collider specifically to kind of act as a trigger zone for pushing the shell. Let's add a new component here specifically for a box collider 2D. It can be any collider, but I'm going to use a box to distinguish it from the circle collider. Let's move this up next to our other one here. We're going to explicitly mark this as a trigger. So you're not going to physically collide with this collider. It's just going to be used to know when you enter within a certain distance or radius of Koopa or the shell, and then that'll trigger it to be pushed. We just need to make sure that the size of this is a little bit bigger than the actual main circle collider. So I'm going to make this 1.25 compared to just the radius 1, or well, radius is 0.5, but the diameter would be 1. So make this 0.25, and let's offset this so it's centered properly. So this gives us enough space, so it's going to trigger the shell to get pushed before you ever touch the actual enemy, which means you won't die when you push it. So let's go ahead and open up our Koopa script. And instead of using onCollisionEnter2D, we can use onTriggerEnter2D. since we defined that collider as a trigger. And this takes in a collider to the other, so it's the other collider that triggered this. And this will sort of be the opposite logic here, where this only applies if you have been shelled. So if Koopa is in his shell, we still need to check that this is the player that is colliding with it. Okay, and then at this point we need to push the shell. However, if the shell is already moving, then we don't need to push it because it's already been pushed. So we can say if the shell is not moving, else. So if the shell is moving already, it's been pushed, and you touch it again, well then at that point you would get hit and you would die. And same goes for all of our other enemies too. So here, let's get a reference to our player script just like we did up there. Player equals other get component player, and we can say player.hit. Okay. So if the shell is not moving, then we can push the shell. So let's define a new function for push shell. And this needs to take in a direction vector because we need to know which way to push it depending on which side Mario touched it from. So we need to calculate what that direction is. And as a complete aside, I think I'm going to actually rename this. I'm going to call this just pushed. I feel like it's a little bit more accurate. Pushed. So if it's not been pushed, we will push it. Otherwise, if it's already been pushed, then it hits the player. Okay, so let's calculate this direction vector. So to get the direction between any two objects, we just subtract their positions. This gives us a direction, or this gives us a vector that points from one to the other. So here, let's create a new vector 2. And I only care about the x-axis. So I'm going to say transform.position.x minus other.transform.position.x. And then for the y-axis, I can just set that to 0. And we'll pass this direction vector into our function here. So for actually pushing the shell, let's set our pushed variable to true. We need to re-enable the rigid body so it can move again. So let's get a reference to our rigid body 2D. And let's set it to not be kinematic. When it's not kinematic, the physics engine will handle its physics and movement. We also need to re-enable our custom entity movement script since we previously disabled that when it entered the shell. But we also want to set a few other variables on this. So let's actually store a temporary reference to this. Get component entity movement. In here, we can set the direction of the shell based on the direction that we pushed it in. Although we need to normalize that because when we subtract this position up here, there's still going to be a magnitude to that vector, and we don't want magnitude when it comes to direction. Otherwise, it would be velocity, not direction. So normalize that. We can also set the speed of the shell. Maybe we define a new float up here called shell speed. And I've done some testing and I found a value of 12 to be it feels very similar to the original game, but feel free to customize that to your preference. So I'm going to assign that here, movement speed equals shell speed. And then we can just re-enable this. Great, so that's good for now. There will be one more thing we need to do in here, but let's test this out initially. Let's rerun this. Okay, so I should be able to push it. So there we go, I pushed it. Great, and it should still kill me. There we go. So it killed me. Now there's one little problem where noticed how Mario was still being animated when, even though it played my death animation, but Mario was also still being animated. So it's perhaps a problem that we should have fixed earlier. But to do that, we just need to disable the run animation in our player sprite renderer. So whenever the player sprite renderer gets disabled, we also need to disable our run animation. And this player sprite renderer gets disabled whenever Mario gets hit. So Mario gets hit, he starts the death, the two renders get disabled, the death animation gets enabled. So in that case, the run animation will get disabled as well, which will make sure that the sprite doesn't get changed unnecessarily. Let's try this one more time. And let's push this again. Now notice how it goes through Goomba. So that's the next problem we need to fix. But there we go. So now it played the correct thing. So we still want the shell to collide with enemies and actually kill the enemies too. So the reason it's not doing that is because we have collision turned off between enemies, which is important. We want to keep that. So what we can do is we can put Koopa onto a new layer once he's been pushed. So we can have like a shell layer. Why don't, in our project settings, we go to tags and layers. You can access your project settings from edit project settings. And I'm going to define a new user layer here called shell. And then in our physics 2D collision matrix, we can turn off collision between, we want to keep collision turned on between the enemies and the shells. But if you did have multiple shells, we can disable shell-to-shell collision though. So finally, we just need to update Koopa's layer after it's been pushed. So here in the push shell function, we'll say GameObject.layer equals layer mask name to layer shell. So that'll set it to be a new layer, which will then allow collisions to occur. Let's test this out. This is still not quite right, but it's the next step in the right direction. So there we go. So we have collision, and of course it doesn't actually kill Goomba yet. So let's go to our Goomba script. Let's add the onTriggerEnter 2D. This takes a collider 2D other. Here we can check to see if other .gameObject.layer equals layer mask name to layer shell. So we're checking that Goomba has walked into the shell kind of radius. And if he has, well then Goomba needs to get hit and die. So let's add a hit function. And we'll call it here. So when Goomba gets hit, we can play that same death animation we used for the player, for Mario. So let's actually go to our Goomba Prefab, and let's go ahead and add the death animation script here. Now there's no death sprite for Goomba, so we can leave that blank. And let's turn that off initially. And that's good. And why don't we do the same exact thing for Koopa? Because in theory, you could hit another Koopa with a shell. So let's add a death animation script to Koopa. There's also no death sprite for him. And let's turn that off initially. Make sure that your layer is still set to enemy. We're only changing it programmatically to shell. It still needs to start as enemy. So just to double check that too. All right, let's go back to our Goomba script. And when Goomba gets hit, we can play that death animation. So we can get a reference to that and just enable it. And we should also disable the sprite animation for Goomba's, what is this called? The animated sprite. Animated sprite enabled false. This will turn off his walk animation, and then we'll start the death animation. And then we can destroy Goomba, this object, after 3 seconds. The death animation lasts 3 seconds, so afterwards, Goomba will get destroyed and be removed from the scene. So that looks good. Now, in theory, we should do the exact same thing for Koopa too. So like literally we can just copy the same function into our Koopa script. This will get triggered. So I guess for now, let me see. So so I guess here we need a different condition to say that, so just like we did for Goomba, on trigger enter. So let's same exact logic in theory. So if the player walked into the shell If Koopa shelled and the player walked into it, it'll get pushed or the player gets hit. Otherwise, if the object that's this should really be not shelled. So in the case that the Koopa is not shelled and it collides with a different shell, so it's kind of confusing because within the same script we're referring to two different versions, like two different instances of Koopa. So for this one saying this Koopa is not shelled, it's walking around normally. But then there's a different instance of Koopa who has been shelled and it's been pushed, and thus the layer has been changed, and you've collided with that. Then we'll call our hit function. We can't actually test this because we only have one instance of Koopa, but really it's the same logic from Goomba. So let's go ahead and test out the logic we implemented for Goomba here. So we hit this and then we push it, and there we go. Goomba gets killed, and so does the player. So there, that's perfect. We've got all of the Koopa kind of interactions with the shell and everything. Is there anything missing from this? I don't think so. I think at this point we're all good. I guess one thing we could do, just like for the, if you remember when we did our entity movement, we set that when they become invisible, so when they go off the screen, they get disabled. The shell should probably be the same thing, where in the original game, I believe if the shell leaves the screen, it actually just sort of disappears. So if we wanted to do that, we can add that same on became invisible function, which is basically saying the object has left it. Oh, this should not be in Goomba. This should be in our Koopa script. So in our Koopa script, on became invisible. If Koopa is shelled, then we can just destroy it. Or really, this should not be if shelled, this should be if pushed. So if Koopa's been pushed, if the shell's been pushed and it kind of leaves the screen, then it just gets destroyed. You don't have to do this, but I believe that's how the original game works. So that's where, in theory here, as I play the game and I hit Koopa, and let's hit the shell, Goomba dies. Oh, oops, I walked over too much. Let me not walk over at all. Try this again. Push it. So it left the screen. In theory, it should come back, right? Or you might expect it to come back, but no, it just disappears at that point because it's off screen. So once again, that's kind of how the original game works, I believe. If you don't like that functionality, just don't implement this function here and you're good. All right, so the final thing we're going to do for this video is implement a death barrier. When you fall down one of the pits, that needs to cause the player to die and reset the level, just like as if an enemy killed you. So let's create a new script called death barrier. And let's go ahead and make a new object in our scene here. I should probably move Mario inside stage here. And let's add a new object to our stage here for the death barrier. And let's add that script to it. Okay. For our death barrier, we need to add a box collider 2D. And this is going to be a trigger. You don't physically collide with this. You just sort of, it just triggers, the player death. And we just need to update the size of it to be basically, it's just going to sit under our entire level. So I think our level's like 227 tiles, and then we can reposition this. Yeah, perfect. Yeah, so this stretches all the way. You can make it just really massive. It doesn't matter, but just make sure it stretches all the way from the start to the beginning at a minimum. And let's position this 1 unit below. So I guess just -1. Yeah, so there we go. So when you fall, you will touch this, which will cause the trigger. It'll trigger it, which then in our code, we will, we will reset the level essentially. Is there anything else we want to do here? I don't think so. I think we're good. Let's go ahead and write the code for our death barrier. So this is very simple. There's not much to this. All we need to do is add our on trigger enter 2D, collider 2D other. And for this, if the object we collide with, if other.compare tag is player, then we will, let's disable the player entirely. So we can just say game object set active to false. So it'll just completely disable the player. So there's no scripts running on it whatsoever. And then we can reset our level. Game manager.instance.reset level. And we'll have a delay of 3 seconds. Now, if some other entity touches the death barrier, they can just get destroyed. So whether that's an enemy or a power-up or something, anything that's not the player can just get destroyed immediately. So we can just destroy other.gameObject there. And that's all the code we need for our death barrier. Let's go ahead and test this out. Oh, I never moved Koopa back. That's okay. Let me just move Koopa back real quick. He's at 107, I believe. Yeah. All right. Let's test this out. Just gotta go find a pit to fall in. Oops, I'm dumb and I just touched Goomba. All right, let's try that again. At least the level reset like it should. All right, so let's fall in this pit. And I'm gonna pause actually because I want to take a look. Yeah, so see Mario, the game object is completely deactivated. Let's replay and it resets. Perfect. Let's test this out for another entity as well. So let's wait for these Goombas here to fall. And I'm gonna pause it here and we're gonna watch it. So in theory, they should just disappear immediately because they just get destroyed. Oh. Oh yeah, they're there. I was like, where are they? I can't find them. So I'm just gonna play this frame by frame here. Boom, as soon as he touches it, it just disappears. So there we go. Nice. And if we really wanted, we can maybe adjust this. So, you know, maybe they have to fall. We could probably move this down actually another unit. That way they, like, after fully past the barrier there, we just got to be careful later on. When we go underground, the player is going to fall from here. So we're just going to make sure this doesn't interfere. So in fact, maybe what I'll do is I'll reduce the size of this by half a unit. And then I can push this back up a little bit. Yeah, so that'll be good. It gives us enough space for Mario to spawn in right here when he goes underground without touching or clipping this death barrier. So, all right, well, that's it. And that's it for this video. I really appreciate you watching this tutorial, and I hope you learned a thing or two along the way. Give the video a thumbs up or down to let me know how I did. Subscribe to the channel to know when the next video in this series is released, as well as any of my other tutorials. If you want to support my work even more, you can become a Patreon member to receive exclusive benefits, including early access to the rest of this video series. Link in the description of the video. Thank you for watching. See you in the next one.